Welcome everyone to ThursdAI Live, our first one that we actually have video, and we're gonna start soon. But welcome to Learn with ThursdAI Live, where if this works out and this actually will be productive and we'll get some positive feedback, we will do a series of these. But for this first one, I want to introduce LDJ Luigi from Nous Research and Alignment Labs, and I'm going to pull him up on stage in a second. And just want to say thank you for Luigi for doing this, because when I joined Whites and Biases, so you can see the logo hopefully right here in this corner, I did not know what they do. So I knew about the product generally in broad strokes, but I'm not a machine learning scientist. And when I was about to go in there, Luigi suggested, hey, they have this cool feature, that cool feature. And instead of learning myself in private, I said, why not do this in public? Why not have my friend Luigi, who co-hosts ThursdAI often, show me how the open source fine-tuners and folks who train open source models and different things, how they use weights and biases. So I'll be able to ask questions. So I'm going to bring Luigi up on stage. Hello, hello. Mic check.
Hey, can you hear me?
Yes, you're coming through
Hey,
loud and clear.
thanks for having me on.
Thank you for doing this. This is awesome. I'm excited. So I will say we already did one of these. We did like a preparation because like I'm excited because like, this is our first live video casting thing. And yeah, thanks for coming on, man. We're gonna walk through some weights and biases stuff together.
Yeah, no problem. Then here I'm just finding this one of the tabs I wanted to pull up real quick. I think I almost found it. And then I'll start getting started on showing you that first thing.
That's awesome. So meanwhile, maybe I should say kind of what ThursdAI is for folks who may find this and are not following with us. ThursdAI started as a Twitter space, talking about every different things about AI. Around the summer, I think June, many folks who tuned into our live streams but couldn't tune on Thursday, they asked us to record. And so I started recording this into a podcast and newsletter. And LDJ started joining, and other folks from different open source fine tuner LLM industry started joining. So Nous Research and Alignment Labs. Luigi, I think you're a member of both. Yes, and we started talking about everything that happens in the world of LLMs and diffusion, and we still do so every week. So we have one tomorrow actually. So you're welcome to subscribe and join us on the live space recording. It's not a video; it's just audio. And we're gonna do tomorrow. We're gonna cover the 1 year birthday for ChatGPT. So that's about ThursdAI, and that's how Luigi, you and I met. And since then, you've been a co-host in many spaces. I've been a co-host some of your spaces, and yeah, now we're doing this. Now we're doing this video thing. I'm excited.
Yeah, and I actually have everything prepared now, I think, and gonna start sharing my screen here. So let's see.
Let's go.
All right. Okay, now let me know if you see it.
I'm gonna pull up on stage right now, and yeah, your screen comes through live. You have 4 tabs, and you're sharing this thing. And let me just like make sure that folks see it as much as possible. And I will suggest for folks in the audience to full screen as much as possible. And all right, I think we're good.
Okay, great. So you can see my screen right now?
Yes.
All right. So here, I'll just give a little bit overview for, people of kind of all levels of experience. So in terms of training, there's different things within AI trainings of all kinds, whether you're doing image-based models or audio or LLMs. There's training steps where you'll have a certain amount of data trained on at a time. That's called the batch. And then for after each batch, you update the different values of, you can kind of think of it as the connections of the brain. That's what we also call the parameters. And so when you're doing this, there's a lot of things called hyperparameters, which are pretty much the variables that can control different parts of how those values are being updated. And that's what kind of these things here are. So you see anchor dropout, which is encoder dropout, mel dropout, weight decay, all these different things. And a little bit of background on this specific thing. Some of these terms might not be familiar to people that specifically do LLMs, because this is actually an old weights and biases account I have from about 3 years ago or so for a company that I actually helped co-found called TTS Labs. And this is a lot of audio specific AI models where it's mostly for the purpose of trying to replicate, let's say, a Twitch streamer's voice. And then in a lot of cases, the Twitch streamer then allows the viewers to actually donate things in their own Twitch streamer's voice, or have things like the automated systems that say, hey, thank you, Altrin, for donating to my channel. So that's a lot of the use case for this. And then in this case, we can just sort by all the runs in weights and biases. In this case, it would be, here, let me unfilter this. It'd be about 29 runs for what we call this sweep. And with the sweeps, it's really smart. There's a bunch of different kind of ways that they have optimized so where they can automatically test out different variables in different ranges. And there's multiple different types of optimization. I guess you would call it optimization presets of how you wanted to test different variables. And actually, Eltrin, you wanted to interject with something?
Yeah, I just wanted to just clarify a question from my end. Watching recent Karpathy's talk about just training LLMs, at least the beginning of this, gave me a lot of like information about like how these things are trained and fine tuned. And there's the code that kind of runs, and there's the file, the binary file that is the output. That's after this process of what you're showing us, right? So the hyperparameters and the data and everything else, that's what goes into the baking of that eventual file. And I think you mentioned this, but like hyperparameters tweaking is a lot of the secret sauce to an extent, right?
Yeah, that definitely plays a role. If you have really messed up hyperparameters, that could really be the difference between a model with the same amount of parameters and same amount of tokens during training performing very well versus pretty good. And usually this is not really a problem with, big companies. Usually they have teams of people like tuning in the hyperparameters pretty well. But this is definitely something to be aware of if you're kind of just starting out, or even just doing things with a relatively small amount of people. And this sweeps feature in weights and biases, where you can actually see here, you can control different sweeps. In some cases, I think you can even have different controls, like pausing and stopping it remotely from here, which I think actually you haven't maybe seen before, Eltrin. But yeah, there's a lot of cool stuff like that. You can even view the logs here. I'm not going to open that because there might be some sensitive information there. But yeah, just different configurations like that. And if I go back to these diagrams here,
Could we define a sweep for folks who've never trained a model or never like even fine tuned?
Sure, yeah. I mean, like even for people that do fine tuning a lot, the term sweep is kind of still a little bit specific and obscure to weights and biases interface specifically. So a sweep would just be, hey, I have this this AI model, and I want to test out. I want to run like 30 different runs with a variety of different hyperparameters, and I want to set a range for each hyperparameter of how many different ranges of values do I want to try. And then I define that for all the different hyperparameter variables, and then the sweep function will take all those things that I define and automatically test all those runs for me in what it believes is the most optimal way. And there's different types of here, if I remember right, there's documentation for this, and definitely maybe link below or however you're streaming this.
Yeah.
There's documentation for, I believe there's I don't want to butcher it here, but like there's linear testing or like tree search that it can optimize for, or it could try just doing like Bayes search and a different kind of searching optimizations like that for how it's testing the different variables. And after you test those, then you can actually come back here. And if I go, I think it's this page, yep. So it kind of looks like a little bit spaghetti. So here I could look at what has the lowest loss, and the loss just means how wrong was the AI model, pretty much. And this is how wrong was the AI model when you test it at the end of training.
Which is the goal is to get to least strong as possible, right? Like to lower
Exactly.
this. Yeah.
Yeah. And so if I wanted to filter by just here, I could just select like that. And then by doing so, I can automatically have highlighted the ones that pretty much perform the best out of all of these runs. And if I just hover over any of them, I can automatically see all the hyperparameter values that were set for that run when that happened. And then I can kind of look at this and try and derive more insights and better insights for future runs that I might do of how I should maybe set certain hyperparameters in order to get these most optimal loss values and most accurate models. So I think I mostly covered that. Also, what's cool is when you actually select
I will,
different
if you
values
don't mind
here.
asking you a question. There's like two columns at the end. There's training loss and validation loss. Could you tell me the difference? 'Cause, like training
Sure,
loss
yeah.
is, yeah, go ahead.
So training loss is during the training, it's how wrong is it at predicting the right answer on the training data that's it's being trained on. But of
Mm,
course, there's kind of a flaw in that process because imagine that you have a 10-year-old kid and you're testing them or you're teaching them a bunch of specific biology things. And on the exact biology questions that you're testing them on, or sorry, on the exact biology questions that you're teaching them, you also end up giving them a test that has those exact same questions.
mhm,
So there's an issue with that where they could just be memorizing things or not truly understanding biology outside of those questions. So that's where validation loss comes in, where you keep examples and you hold them off to the side that you specifically make sure to not train the model on, and you hold them out on the side for the purpose of testing the model on its ability to do accurate prediction on that.
mm.
And so
So
the
you
val.
have some
Mhm.
data that you've prepared with questions and potentially the correct answer. Um,
Yeah, so for LLMs, for if you were doing LLMs and specific fine tuning, like what we would call instructor conversation fine tuning, that's when you would have questions and answers, and in some type of a little bit more complicated cases, you have question answer and then another question, another answer, all in a back and forth conversation.
mhm,
That obviously gets a little bit more complicated of how wrong it is because it could be wrong in certain parts and right in others. But if we just simplify it as question and answer, then I think you could see how, of course, validation loss is typically going to be a better measure than this.
mhm. And for models that are like audio, what are you measuring? Are you measuring like different just quality based on the other parameters?
Yeah, that's a really good question. So it's already difficult as is to try and measure how accurate an LLM output is
Mhm,
without like a human's input on that. But it's in some sense even harder, I think, for audio systems because it's there's not really exact words that you could try and look for because then it's audio. It's not in the form of text characters or anything
mhm.
like that. So there is something called mel spectrograms. Here I could just Google that here and show you. So mel spectrograms are or some spectrograms. It's a more accurate visualization of audio than what people might typically see as like a waveform.
Mhm.
This is what most people are familiar with when they think of an audio visualization. But this actually kind of shows you how strong or how loud certain pitches were in the audio and at different points of time in the audio. So a lot of checking for loss when it comes to audio or certain audio models at least is actually converting the audio into a Mel spectrogram, then comparing the images of the Mel spectrograms of the correct desired audio in the data set versus what was the audio that the model predicted. And then you compare those and see how close they are. And then you derive a value off of that of how wrong it is. And that's not the exact way that the loss is measured, but that's kind of a rough, simplified overview of how you can kind of derive
Mhm.
how close it is to the right answer. Does that make sense?
Yeah, it does. So you have, let's say you're trying to replicate my voice, for example. You have an actual recording of my voice, and then you train the model to be better at replicating my voice. Each iteration generates a certain audio that
Hmm.
kind of tries to sound like me, and then the Mel spectrogram for my actual voice is compared to what it generates, and
Yeah,
the
that's one
closer
way
it
of
is,
doing it.
the lower
Hmm.
is lost, right? Something like that.
Yeah, so that's one way of doing it. And there's also just the factor of so when you're doing text to speech models specifically, the question would pretty much just be the text, and then the answer would be the audio you have of, let's say, you, Alex, in the data set.
Mhm.
And so you're inputting the model, just the text, and then the answer it has to try and predict is how you would say that text. And it gets a little bit more complicated when you're talking about maybe models that have multi-speakers all in one model and things like that. But in this example, I'm just talking about a model that would be trained to
Mm.
just do a single person's voice.
I see. Yeah, that makes sense.
Okay, so if we go back here, another really cool feature for the interface is you can actually see a different value. You could pick different values here that usually are automatically populated pretty well. And I could see parameter importance with respect to then here. And when it says parameters here, I think it's mostly meaning actually hyperparameter
Hyperparameters,
importance.
yeah.
hmm So
So again,
here,
hyperparameters, just for me to understand,
mhm,
also for folks, there's like different like knobs of different things that the model, when it gets trained, it tries to do, right? So you said mel, there's mel spectrogram, the thing that you showed us, and there's a mel dropout. I assume they're related somehow. And so when you like
mhm.
control the mel dropout, like the outcome of the sound is different. I assume, is that a right like approximation of what a hyperparameter in this context is?
Exactly, yeah. Yeah, so that would be right. So the hyperparameters can kind of be thought of as the different knobs and sliders that you would mainly be kind of wanting to control or change that could change how the model ends up training on the same amount of parameters and same amount of data.
Mm. And aren't there like hundreds or thousands sometimes? Like what are we seeing like six?
So
How does that work?
usually people wouldn't even mess with some of these. Like a
Mm.
lot of times people wouldn't even mess with dropout values or weight decay, especially not for certain LLMs. And I would say for the most part, you could probably narrow it down to less than a dozen hyperparameters.
Mm.
Usually it's, I would say, even like less than five that people would usually modify. But when you really want to get really experimental, or maybe even just for the sake of gaining an intuition of what different hyperparameters do, I think this is useful for a wide range of people doing things like that.
Awesome.
And then here, this feature, or this kind of interface panel, allows you to automatically see something that weights and biases does in the background of
Mm.
trying to see which hyperparameters maybe have the most importance or correlation to your goal value, which in this case is validation loss.
Mm.
So I think that's pretty neat. And I think
So
we've,
this is a way
mhm.
that weights and biases, like just system interface, helps you identify which of the knobs that you move or could move correlates to like which outcome, and you define the outcomes as well, right? So you can say it's training loss, you can say it's validation loss, and I think
Exactly, yeah.
based on what you said, validation loss is the one that we want to try to optimize, because then
hmm
it's outside of the training data set. So we actually want to see if the model performs well in like a real world scenario to an extent.
Yeah, and it's not the perfect. There's even some other things called test loss, and it gets a little bit more complicated than that. And there's a bunch of other, of course, there's benchmarks and things like that, which are technically still even different than validation loss or test loss.
Mm-hmm.
But for the most part, this is like a decent proxy, especially when you're first learning,
Mm-hmm.
to try and gain an intuition of different things. Um, yeah, and what's really cool actually about this too is when I select different ranges of runs here,
Mm-hmm.
what's this doesn't really tell the whole picture when it says a certain value, because for example, the minimum beta or maximum alpha, and also some people might not, even some LLM people might not be too familiar with these values, but here these are just labeled as learning rate and momentum for those familiar with AI terms. And what we did here is throughout the training, I set a minimum learning rate value that it would go to, or minimum alpha and maximum alpha. And the reason why I'm pointing this out here is because when I select the different ranges of runs, I could actually see how those changed throughout time uh, for different runs here.
Mm-hmm.
Where you can't see how it changed throughout time, it just tells you a solid value for each run here. Does that kind of make sense, Alex?
Yeah, yeah. So
Like this gives you more information. hmm
once you zoom in, you're able to see throughout the iterations. Could you tell like the steps? Could you explain the concept of the steps, the 5K and 10K, for folks
Sure,
that don't?
yeah.
Yeah.
So when you're training, let's say you're training on 30 examples per batch. So every batch, that's when it would update the values of the brain connections, you could think of it as. And so each time you do that, that updating of values, that is one step. So
Mm.
here, 5K steps would be the 5,000 of those updates. 10K would be 10,000 of those updates, et cetera, et cetera. Does that make sense?
Yeah, it does. So obviously that has correlation to how much money you spend in compute on every model, right? The longer you
Yeah,
train,
for sure. Yeah.
yeah.
And usually, unless you're doing some batch size scheduling, which is like changing the amount of examples over time, like sometimes people do something where they'll change the amount of examples per step. So the amount of examples per batch that they're doing, and then that can have like some variable costs of like the steps later on, maybe costing more or less than the steps earlier on
Mm-hmm.
technically. But for the most part, 10K will be twice as expensive as 5K steps. 15K will be linearly as expensive, etc.
Mm-hmm.
So I think we mostly covered the sweeps thing here. If there's a question you had of this before you want me to move on to the next thing.
So just to try and summarize, let's see if I can miss some stuff. Sweeps are hyperparameter optimization technique that hyperparameters have different outcomes the more you play with them, and some of them are not to be played with, but you want to keep them in check. And this is a visual representation of different hyperparameters that correlate to a specific outcome in models. In LLMs, this would be performance of correct answers, let's say. And in this case, a TTS model, it would be a generation of a sound based on the training and examples. And yeah, go ahead.
Yeah. Yeah, exactly. And then even you could do something like even stable diffusion.
Hmm.
It's kind of the same overall concept of, I haven't personally really trained stable diffusion models, so I might be getting a little bit of this wrong, but I would assume it's something along the lines of you have some text as the input that ascribes to the desired image, and then you have a goal image that you would like the model to generate something similar to, and then you're measuring how wrong is the predicted generated image that it did compared to the actual desired image that you wish it did.
Hmm.
And then you derive like, different measurements based off that. And that's of course what you'd want to optimize for. So
Yeah, that makes sense.
and of course, like even in that, there's a lot of nuances where it gets a little bit counterintuitive sometimes, where loss can sometimes even inversely be correlated. And I can maybe go over that later sometime, or maybe in
Hmm.
another session. Um, but if you just think about, for example, if you have a certain question with a smart LLM that you're trying to train, there could be multiple very different ways of answering the question correctly. But then when it's trying to derive a loss value or trying to derive other similarities between the desired right answer and the answer that it gave,
Mm.
then it might look like the answer was pretty much wrong from those measurements. But then when you actually look at the answer yourself, you realize it actually had a really smart, correct answer. It was just phrased and using very different words
Hmm.
than what you initially were desiring.
I think I remember something like that from folks from Fuyu, from um, the model that we saw, like a multimodal model. They
Oh, the
talked about
multimodal model. Yeah.
they talked about specifically kind of evaluation sets in this sense, where the model would kind of guess correctly what's on the picture, but the evaluation the evaluation data sets had a different thing they would expect, and so the on the multi-model evaluation sets, the model would score lower, even though it did the thing correctly. And if you actually, as a human evaluator, you would watch the answer about this image, you would say, hey, this actually does describe the image to an extent, but the data set evaluation kind of expected something worded differently. So it kind of reminded me of that.
Yeah. Yeah. And here, I'll move on to the next thing here.
Yeah.
And yeah. And so this is actually something where another feature I think could be really useful regardless if you're doing audio stuff for stable diffusion models or LLMs,
Mm.
is even the process of just comparing for yourself different points in the training
So,
and
so
different.
just
Mhm.
sorry to interrupt. Just 1 second. We're seeing a completely different view. So previous view was like a working
Oh
view.
yeah, I should explain how we get here. Yeah.
Yeah.
So the way you even end up there, and I'll just go back to this tab real quick. So that's in reports. You click on reports, And then when you do that, here there might be some sensitive stuff in reports here, so I'm not going to click
Yeah,
on
we'll
it
talk.
right now. But when you do click on reports, it's really easy. Actually, here I can show. So you click reports. I think you click create new somewhere in the top
Mm-hmm.
right, and then you end up with something like this, where I can't. It won't let me edit it right now because I'm not logged into that Weights and Biases account. But usually it lets you edit this stuff really easily, and it's
Mm-hmm.
very intuitive. You can very easily pick what type of charts you want to show up, and these things usually auto populate. And here, the process of being able to compare different points in the training is kind of visualized here. And usually the method that people would usually have to do, regardless of whether they're doing image diffusion models or LLMs or audio models, is they would have to download the checkpoints of the training. And checkpoints would be like, let's say you save the model when it's at 10K, and then you save the model when it's at 20K, and you have all these different model files.
Mm-hmm.
So you would usually download the checkpoints from the server or from wherever you trained it at. And then you would have to ask the questions that you want to those individual checkpoints, and then like do that for each checkpoint, etc. But
So
this,
the like a person without something like what we're seeing here. Let me try to recap how I would do this. Let's say I didn't know about weights and biases. I learned to fine tune whatever. I can do this on my machine. So I buy like a machine connected with a, GPU to train that model, and then I can SSH into this machine or connect remotely, let's say, and then I start the run. I do all the things. I collect all the data. I find the trainer, the accelerometer, or whatever I use to do this. I have the data. I start the run, and then I basically don't do anything else. Right? Like it takes a while. 10K steps. It takes a while, and so it takes a while to get to 20, etc. But you're saying in the meantime, let's say the model trains. It got to 10K. I want to see how well it performs at that specific kind of step. So there's the loss that we see on the left here, but also there's the actual what it does, what it produces, like how
exactly,
yeah.
yeah. And like I was saying earlier too, there's some flaws even with validation loss, and there's things
Mm-hmm.
like test loss that tries to solve some of those flaws, but
Mm-hmm.
then there's still, sometimes those don't exactly correlate with human preference. And then of course, I'm sure you've heard people complaining about even benchmarks sometimes that are
Yes.
usually used to compare different models. And those, have many wide-ranging flaws of different kinds as well.
And
But
so
usually,
you wanna like smell test your model or test it
mhm,
yourself, and the standard way would be like logging remotely after a while that it runs, downloading a checkpoints file. Checkpoint is like at specific intervals that you predefine. I
mhm.
guess it saves the whole effort, like the whole work that you did so far, and then
Exactly.
you
Yeah.
download this to your machine, and then you would run it with inference or some sort.
Exactly. You
Mm.
would you'd run it, and when Alex says inference, to just, in case some people aren't familiar with that term, inference is pretty much just the term for processing, or you're asking the question to the model and getting an output, or giving an input to the model to get an output outside of training.
I like the
Mhm.
activating the brain metaphor.
Yeah,
Yeah.
activating the brain for a response. Yeah.
Yes.
So here, the reason I bring up that whole workflow of what people would usually have to do to compare different checkpoints is because weights and biases actually offers a much more seamless way of doing so, in my opinion.
Mm.
And I do want to be clear that weights and bias is definitely, not the only possible way of doing this. I
Mm.
know there's multiple big companies that have more efficient, streamlined ways of comparing checkpoints and things like that.
Mm.
But for a lot of people, definitely with very small teams or people doing things individually, I know, people that definitely shouldn't be checking things manually and downloading checkpoints like that, unfortunately, are.
Yeah.
So what I think is much better is this feature here. So this is an example where I can actually go to virtually any interval of steps in the training process,
Mm.
and it will automatically show me different outputs using that step checkpoint. And this is, a little bit more generous in terms of, for a lot of larger models, it won't be really practical to have like 100 different checkpoints saved
Mm.
sometimes, but at the very least, usually you'd have at least, 5 checkpoints that could practically be stored even for some larger models. And then that allows you to go to those intervals And then in this case, I have just a bunch of pre-selected questions that are always asked at each interval. And then an output is generated from that question, or sorry, in this case, it would be text, and then getting the model to try and speak out that text. And then I can compare them.
Mm-hmm.
So here, if I
don't think we can hear.
Oh, there's no audio. Okay, thank you for letting me know. Let me switch here. Let me click stop sharing, and then let me present again.
So just to kind of see if I understand this correctly, there's code that trains the model, and also there's code that says at every interval that you defined in advance, run the model on these texts, generate audio from these texts, and then the outcome of this, save this as an artifact somewhere, probably somewhere with weights and biases system.
Actually,
true?
yeah, that's another feature. So there is actually a feature called artifacts and weights and biases. I personally really haven't used it much at all. And back when I was initially doing a lot of stuff in TTS Labs and a lot of the audio AI stuff we were doing, I think it was a new feature roughly around 2021, I want to say. But at this point, it probably maybe even has more features than what I initially remember. It's been a good 2 years since then.
Yeah.
And I'm going to try to open up this link and see if I can.
So for while you open up the link, for the audio that you showed, the actual kind of audio files, you store them somewhere, and then how does like the interface know about at which step which audio files to kind of let you play? You just do like a reference to a file somewhere in the cloud?
I might be able to show that a little bit here, but in the interface, when you're creating a weights and biases report, or when you're even editing your weights and biases dashboard, so in the documentation of the code, within the weights and biases code that you integrate, you pretty much decide what type of data and which data you want to log. And so when that data gets logged to weights and biases, and then you start modifying the dashboard or the report, it usually will auto detect something like the audio examples and the audio and things like that. And then you can just select that. And then it's very smart and very good at pretty much just being able to automatically visualize that in a nice looking way. Yeah.
Awesome. Okay.
So here, if I do this right, sorry if I'm stumbling over my words a little bit. I'm multitasking, trying to get this real quick. Yeah.
Sorry, take your time.
Chrome
so far,
tab.
We had Andrew through LinkedIn post a link to the sweeps documentation, so I'll show up.
Oh, thank you, Andrew. Okay, and can you see my tab now?
I just added your screen back, yes.
Okay, nice. So now you guys might be able to hear this.
Let's try.
And what's interesting about this model, actually, so this is a very old model when we were originally using some things. So some people in the audio AI space, they might be familiar with a lady named LJ. She has probably one of the most popular long form audio data sets of relatively high quality voice, where a lot of people use that for training some base models, base AI models. So in this case, if I go to step 0, what's interesting is you can actually hear the female voice here. So if I just inference or play this.
Generative adversarial network or variational autoencoder.
And then this run was effectively fine-tuning it, and over time you can hear it become more of the male voice of this New Zealand streamer.
So this was like step 0. Step 0, basically the model doesn't know anything. It's brand new.
That's step 0 when no updates have been made to the model at all. So it's just, And then this would be step 10,000, or here I can even go a little bit earlier. Even if I go a little bit here, you should be able to hear a lot of difference. So
generative adversarial
so it sounds mechanic, but that's because like it's very, very early, right?
Exactly. And there's kind of an interesting saying sometimes, and that some AI people will say, like, sometimes it has to get worse before it gets better. It's kind of like a thing, philosophy in life, and it's a cliche, but it is true sometimes. Sometimes it does get worse before it gets better. And then if I progress here,
generative adversarial network or variational autoencoder.
And then if I just go much more,
generative adversarial network or variational autoencoder.
And so the slider is just like
it's just skipping to that step of the checkpoint that was saved at here around 32,000 steps.
So you actually have 32,000 checkpoints?
So I don't think you can actually increment it. You see, when I go down, so it's saved every 50 steps.
50 steps. It's still like a lot, right?
It still is a lot. Usually wouldn't be able to have this amount of models saved for the large LLMs, like even like 7 billion parameter models. Like you usually wouldn't have this many checkpoints saved. But a lot of the audio AI models just end up being kind of relatively small. To where I want to say this was in the range of like less than 500 megabytes per checkpoint, or per model save, which is still relatively large. But we had a lot of storage and stuff for these checkpoints. So that's an example of that. And I think if a lot of people that are watching this and are doing things like fine-tuning LLMs or fine-tuning Stable Diffusion, LoRa's, or anything like that, they can kind of think of this as, imagine just having a set of prompts that you can just have in a file somewhere, and then you can set a value of how many steps, or let's say every 50 steps or every 500 steps or anything like that, is when it will inference and test the model on all those different prompts that you had in that file. And then you could see maybe how do the Stable Diffusion images outputs look like at those different intervals. And you can immediately see that without having to download those Stable Diffusion LoRa checkpoints and inference it manually yourself. Or same thing with the LLMs. You can have a set of questions, and then every amount of interval, you could see how the model actually was responding, and you can judge for yourself how smart or how creative do those outputs look throughout the training.
I will say that that's not necessarily evals. When we talk about benchmarks and evaluations, that's not that, right? Because there's no score at the end of this. You just get kind of the raw output for you to kind of
it's more of just getting your own subjective, really getting your own subjective opinion on that. And sometimes it can really actually help with the hyperparameter choices, or even like the dataset choices or anything like that, because maybe you notice something along the lines of, like, you might notice something weird, like, oh, my LLM is having, and I'm not sure if this would exactly happen, but like maybe my LLM looks like it's getting more creative, like here, like in the middle of training, and then towards the end of training, it starts to be less creative, but more smart in terms of STEM subjects. And then there might be certain counterintuitive things like that might happen. And then that can kind of go more towards your decision of, okay, well, I'll purposely want to pick like the middle checkpoint for people to actually use, because my target audience, for example, might want to use more creative things and are okay with less STEM abilities. And when I say STEM, I mean science, technology, engineering, and math.
So it's not necessarily all the time true that the longer you train, the better the model gets, or at least depending on which better you're looking at, right? If you're saying creativity, it could be creative during the middle of the run and then kind of get lost.
Exactly, yeah. And actually something we discovered with LLMs and Nous Research and some of my colleagues, Technium and others, it's actually very counterintuitive to a lot of people. But like I was saying earlier, even validation loss can sometimes actually be oppositely correlated with human preference. And it sounds, very counterintuitive and very messed up and things like that. And there's a lot of kind of explanations, like I was saying earlier. You can have, let's say, a very different formed answer than what is expected, but still be right. And this is the kind of the trouble with trying to have automated systems evaluating very smart systems. They're very smart models.
So just going back in terms of just weights and biases, this is a report that's like a public link that you and your team kind of created and can share, right? You said that you're not even like logged in to be able to edit this, and that's live, right? All these dashboards and metrics, they update as the model kind of trains. So you'd
Yeah,
always be able to go there?
actually, I'm sorry, repeat that. The
No, I
last part.
said so you'd always be able to go here and kind of replay the latest steps. You don't have to download anything or go anywhere. Like the interface will update as the model keeps training.
Oh yeah, actually, yeah, that's a good point. So yeah, this actually updates live. And so this is connected to the run information. And what's cool too is you can have a private weights and biases account, which this account is private. But then what I can do is when I create this report and select this run for the information to be attached to, I can select to have that be a public report that
Yeah.
anybody with the link can look at, or I can select for it to be a private report where people only with access to this weights and biases account can see it.
I actually saw a cool example of this in real world today. Maxime, somebody
Oh
I don't
yeah,
know
I
if you
think you
saw.
sent me something along
Yeah,
those
yeah.
lines. I can click on that now.
Oh yeah, so that would be great. So I'll just say this. So there was a person who used Technium's Open RMS 2.5 and continued training us on another data set from the Intel folks, and then released this model and said, hey, this model likely performs better on different benchmarks. So basically took an existing fine tune that Technium already released and is widely regarded as one of the best ones that are out there, at least as far as I'm aware, OpenRMS 2.5, and then continued training this on this new data set from Intel. I keep forgetting what it's called. And
Me too.
showed like better performance. I'll go check after I stop talking. And then somebody, Cassius, the guy behind or the maintainer of Axolotl, a software that you guys use to fine tune, if I'm not mistaken, that's what Axolotl is. He just asked for the weights and biases report because he saw that that person, Maxine, he posted the training losses, and those charts are very specific, right? Like this chart that we have here with training loss. It's very very specific to weights and biases. So when somebody posts, the other people know that you've tracked that run with weights and biases, and they actually shared this information back and forth in the form of a weights and biases report, a public report, which I found very cool because I was like, I'm new here, but like it's really cool to see that people are building, fine tuning, and then also kind of sharing info in this way. I literally looked through it and I did not understand a lot of stuff. Like I did not find it very helpful for me.
Yeah, no problem. I think you could see it here on my screen, right?
Yes.
Yeah, so I don't think maybe there is a report link, but
Neural Chat was the name of the
yeah, Neural Hermes 2.5
yes.
here. So I'm not sure if there was if this is what you meant by report, or if there's another link.
No, he shared, I think, the run. Yeah, I think I confused.
Okay,
there
yeah,
wasn't like a
so
nice written up report. He shared the actual run dashboard, right?
yeah, so I think what's cool is, and I'm about to test this for myself now, but I think when somebody makes their project public, which he did here, I think that allows people like me to even create a report. Okay, no, I can't. So that would have been cool if I could create a report of somebody else's project, or maybe you can, and maybe
there's a
it's
button
bugger.
on the top right there. Can you hit that and see what happens?
Create report. Okay, let's see if this allows me to. All right.
Same thing.
So this is either a bug or I'm not allowed to. But either way, I'm sure you can talk with the people over at Weights and Biases and see about
we'll
that.
Ask.
Yeah. And what's actually cool about this, which is pretty ubiquitous across different runs, it very easily logs your system information that you can then remotely see how much memory is it accessing, even like temperature of the GPU throughout the run. So much useful information here, which, like, if I'm being honest, a lot of times we won't check it, but it's nice to have that sometimes if we need to, we can check it.
Yeah. So the one thing I know about this for sure is that, hardware and compute is one of the most expensive resources in this whole endeavor, especially for huge companies that are doing like big runs, like millions of dollars worth of runs. And for them, utilization is not necessarily for the ML person that trains the model, but definitely for folks who are like doing ML ops. That's critical for them because a hiccup there could cost like in the order of like hundreds of thousands of dollars. So definitely monitoring this visually helps. I want to ask about this though, because like here, the graphs start at some point after 60, 70,000. You see that? Like everything is like flat.
Yeah,
What does
I'm
that?
not
Do you
too
know? Do
sure
you have
here.
any
If I
idea
go
what it means?
back, a little bit,
Like pretty much
yeah, I'm not
all
sure
these
because
like
here it's like the opposite. Here the GPU is being used the most, and then the utilization drops around 70. But then I think like here system memory utilization. I don't know. That might be because maybe like when the run is finishing, then there might be some type of process at the end here that it's higher memory utilization because maybe that's when it's like saving a bunch of things or something. Or actually that might be if he did with and this is really pulling at straws. I might be completely off here, but if he's doing something like LoRa or QLoRa, the kind of the typical process now is you would want to merge the LoRa or the QLoRa weights, and you know there's a bunch of other nuances that I can kind of go for a little bit explaining that, but yeah, there's a merging process that happens at the end, and that might be why the memory utilization is going up here a lot, while the GPU utilization is going down.
Yeah, I see. But it's really cool that like it like so the weights and biases SDK that you import in order to get all this, that also does all of the monitoring as well, right?
Yeah, so pretty much in almost any weights and biases link that somebody shares, like you'll usually see, and like if they have their full project public, you usually see this stuff like logged, and yeah.
I see. What else is logged here that could be interesting? Let's say
So
Technium
here
wants to look at
there's these things.
yeah.
So I can explain a little bit of what
Yes,
this
please.
is. So here, train/learning rate. So this is the learning rate schedule, it looks like, where this is the amount of steps you see here. It says train/global step. And the learning rate is, this is the value that you usually modify that determines what is essentially the max amount of change that each weight update is allowed to do to the connections in the brain, in the virtual brain. Does that kind of make sense?
Can you
So
rephrase this just one more time from another
yeah, no
angle?
problem.
Yeah.
So here I'm going to try and think about how to simplify it. Okay, so this is, I'm just going to use some arbitrary numbers as an example.
Yeah.
So let's say that each connection, or what we would call it like equivalent of synapses in the brain or connections, let's say each connection has a value of 1. And then if you set the learning rate to 0.1, then you're allowing the value of any connections during any step to, at most, be changed up or down by a value of 0.1.
Okay.
If you set the learning rate higher, then you're allowing the model values to change for any connection like at a higher value for any given step. Because each step defines, each time a step happens is each time an update happens to the values of the connections.
So like it's just how much change happens per step. That's the learning.
Yeah,
rate?
how much change is allowed to happen.
Allowed to happen just
Yeah,
generally to the whole
like a
thing.
maximum.
Yeah.
Yeah.
So if you set that like crazy high, then you'll get like different results.
Exactly. And
yeah.
so theoretically, some people might think when they're starting out, oh, like why not just set the learning rate as high as possible then, and then the training will happen just super quick in like 2 or 3 steps. But it doesn't really work that way, and for a variety of reasons. But so this is what we call a learning rate scheduler, where you're actually changing the learning rate over time. And this going up here is what we would call a learning rate warm-up. And so usually the value, I'm guessing here, the value that they set in the config was probably this 0.00005. I guess that's like, that would be equivalent to saying like 5e minus 5 or 5e minus 4. I think it's hard to see the amount of zeros here. But yeah, it would be that value. And then in the config, they probably also specified something like 100 steps for the warm-up. So it's pretty much just saying that it's going to slowly bring up the learning rate for the first 100 steps before it gets to that learning rate value that they set in the config.
I see.
And then this is usually...
question here. This would be defined, let's say this Maxine person and Maxine Lebon, I think that's the last name there in the projects. So thank you, Maxine. We're using your thing live.
Yeah.
He would use something that the Intel folks kind of published with their paper or their like announcement or whatever in order to replicate the results?
So from what I understand about that, and I only very briefly heard about it anyways, but the data set I think he used, it's something we call DPO, where there's a lot of nuances in that. But to like simplify, there's and I haven't looked at the data set myself, so I don't know if this is exactly the case, but I believe it's one question, for every question in the data set, there's two responses, a worse response and a better response. And they already have it defined in the data set which response is better or worse. And so then the training method, DPO, which stands for direct preference optimization, I'm guessing he continued training Hermes like on that data set with that technique to pretty much give Hermes more information and I guess theoretically just a better understanding of what is better and what is worse.
So Hermes at that point already like was a well-performing model in terms of instruction fine-tuning and
yes,
checks and
and it's
everything.
impressive. Sorry, what is their name? Maxime?
I think it's Maxime. Yeah, Maxime
Okay,
or
yeah.
Maxime,
So it's impressive. Maxime was able to. I think it was either Maxime or Technium benchmarked it, and it did show like slight improvement. And I think it's impressive they were even able to achieve the slight improvement because there's so much training and so much data and so much diversity of data that went into already training Hermes that it's really looking bright for different techniques like DPO and for the data set that Intel used for this. Or sorry, not Intel didn't train this, but I believe it's a data set that came from Intel.
Yeah, Intel the data set that was trained to that was used to fine tune another Mistral fine tune, and now it's very interesting if this one is better than that one on different benches. So you would see it this and the train loss thing does not look like any train loss that I saw previously. It kind of drops to zero real quick. When you look at this, what do you get from this
So
chart?
this must so when you're comparing different models or different runs, the loss value is not really something you can compare across like different models or even like different runs of the same parameter model. So it's like a little bit kind of non-comparable in that sense. But here, what are the values here? So you see, it never really truly gets to zero. It just gets to a number that's so relatively low that it just kind of looks like zero. I'm guessing usually regardless, like I usually wouldn't, see it look like this anyway. So I'm guessing this has to do with something about DPO or the training technique that was used that makes this curve look like this. Yeah, but it doesn't really necessarily mean that like it's 10 times better than the other model that has a loss that was like at 1 or something like that. You know what I mean?
Yeah.
Yeah.
So every like type of model, even data set, you're saying affects kind of the training loss metric.
Yeah, there is kind of like a general rule of thumb, which it's not really like too objective, but just in my experience specifically with fine-tuning LLMs and me and Technium's work and things like that, usually it will be somewhere in the range of 0.1 to 0.5 that the training loss will be at by the end of training. And usually the validation loss will be roughly around there too, or usually the validation loss will be like between 0.2 and 0.8 roughly by the end of training. And here, I think there's one last thing I want to show, and this actually kind of involves somebody who also is quite a frequent attender to ThursdAI, which is Farrell.
Yeah.
And he actually has something which this is kind of an early version, and he said it's being improved, and he plans on coming out with a better version soon. But this is called Dharma that I'm about to show now. So let me know if you see a different screen. Okay.
Worthy Night 100.
Nice. Okay. So this is actually weights and biases link from just in the past few months run that I did within Nous Research with one of my colleagues, Zilla, also known as Jeffrey. He also worked on the Yarn paper that some people might be familiar with of extending context length to 128K.
Well, let me shout out. If they don't know what we're talking about, there's a whole episode on ThursdAI that Zilla and Bowen and who else there was? Bowen and Technium, I think, as well, and you.
No, so me and Technium weren't involved
Enrico
directly. Well. Enrico.
Shipole, Jeffrey, who's
and Bowen.
And Bowen Peng.
And I think there might be one other person, but They know who they are. Yeah, it'll be mentioned in your ThursdAI episode. Yeah.
So absolutely you should check out because it's fascinating. And now I will learn way more about what I was like getting from them last time. But yeah, go ahead. So Mozilla is involved in News Research. I think a co-founder of News Research.
Yeah, and usually we just run the things on his through his through Emozilla's weights and biases account here, and I have a model called Puffin, a data set called Puffin. It says Puffin here, but that's just a little bit of a misnomer. This is not actually a run from my Puffin model, but we just call like any runs that I'm involved in, we just call it like within the Puffin group of models, just because that's how it started. So here we could see the evaluation loss going down. I think I've kind of somewhat explained, what that means. But here we see all these other things that you usually wouldn't see. You see bench accuracy, arc easy, bench average accuracy, all these different things. So this is actually part of a system that Farrell did called Dharma, which kind of aims to have something a little bit more correct and objective than just loss measuring. And what this does is just periodically, it will kind of benchmark your model on small subsets of different popular benchmarks. And so instead of benchmarking your model on entire benchmarks and many of them, which would usually take a lot longer and be a lot more compute, it just periodically does these subsamples. So here, bench average accuracy is just an average of like all of them. And you can see how this changes over time. Arc Easy is just the name of another benchmark. When a Grande is the name of another benchmark.
So those are like Arc Easy. Those are like quick benchmarks that it's like feasible to run in the middle of the training run to just like quickly get a measure.
Yeah, so these are pretty much very, very mini forms of popular benchmarks that Farrell curated.
Nice.
And there is like some flaws with this, that he's improving these things a lot and coming out with better versions, he tells me soon. Or I don't want to promise and make him obligated to come out with something soon. But I know within the next few months, I think we could probably expect something pretty cool from him that people could use.
So let me just because you showed me this before, and I think I'm getting very excited about the concept of it. So there's like a new panel on top that says eval. And so previously we saw like system, there's a system panel everywhere. This actually runs on every step or a few steps, like the output that we saw in the music model that you showed. This, instead of just generating sound, this actually generates responses or generates specific responses on this evaluation benchmark.
And then automatically gets scores for the benchmark.
Automatically gets scores for the benchmark, and so you could see whether your model improves like throughout time based on the very quick benchmarks, and you can see it live. You don't have to like download, like we said, download the model and run like the evaluation hardness, I think it's called, or
exactly, yeah. So yeah, like you said, it's a huge benefit. You can just check on it live. You can even create a report that updates live with all this information, and then you just send. For example, you could send that link to yourself on Discord or wherever, and then periodically just check that link on your phone. Let's say you're on vacation or wherever, and even when you're away from your desktop or your computer, you could see actually live how it's doing and the different evaluations.
I will propose this as a marketing slogan for Weights and Biases, like train your models from your vacation with a peace of mind.
Yeah, and unironically, I have been in a decent amount of situations where I'm in the hot tub or I'm out walking my dog and just click on the Weights and Biases link, and just very seamlessly I'm able to check the progress of different runs.
That's awesome. And this like evaluation flow, that's not something that many people have, right? Just like built in here, evaluation within the dashboard, shareable with everyone. That's super, super cool. So
yeah, so usually large companies will have kind of some systems where they can like have something roughly similar to what I'm demonstrating here. But yeah, shout out to Farrell. He's working on cool stuff like this.
Super cool.
And ideally, when you have these things working well and everything, you have a system that you can actually have, let's say maybe a benchmark that measures specifically things like creativity, and maybe another one that's measuring things like multilingual capabilities, and another one measuring STEM abilities. And then you can maybe see if throughout the training run, your model is maybe making trade-offs where it's increasing in one and not the other. And you can maybe use those insights to try and, pick one of those trade-offs that you might want to do, or change how your model's training for the next run.
Wow, that sounds super useful.
Yeah. And then again, always, like it typically shows the system that it automatically logs. And I noticed, so it seemed like you noticed here, it says eval and then train. And so the difference there would be here, you see eval loss is automatically sorted here. And this is actually a smart thing that I noticed weights and biases seems to kind of automatically do a lot, where it will, in your dashboard, automatically separate things into an eval and training section, and then it'll show things like the training loss here, and it'll show things like the evaluation loss and other evaluation related things here.
So evaluation loss is like a separate metric only if you have evaluations that run on every few steps, right?
Yeah, so typically at the very least, most what we would call them like trainers is like the code that actually controls the training of the model. Usually the training code will just have something by default that just asks you like, hey, what percentage of your data set do you want to set aside for evaluation? And that's called like the train and eval split. So if you have like a 20% train and eval split, that means you're setting aside like 20% of the data or whatever to.
Oh, it happens automatically by like the trainer or axolotl or one of those
Yeah,
tools that you guys use?
Exactly. So like things like axolotl and other trainers will like not even just for LLMs, but even for like I'm sure diffusion models, and especially I know from audio AI systems, like a lot of these the training code already kind of assumes that you want to set some data aside for evaluation. Yeah. And then again, just to reiterate what that means, like to set it aside, it just means you're setting aside certain data that you're making sure that the model is not training itself on, and it's making sure the model is not allowed to update itself based on the results it gets from this. So it's kind of like testing the kid and then not telling the kid what score he got on the test.
Yeah.
So yeah.
So Luigi, it looks like we're coming up on an hour and something.
And I think we
started.
just about finished pretty much all the
That's
things
awesome.
I wanted to show you. Yeah.
Wow. So you had one last thing that you want to show, or are we?
No, that's
over?
Yeah, everything we showed, and I guess I could just give a recap of everything I showed. I showed the system of this is called Dharma that Farrell worked on, and he's coming out with better and improved versions of this. And then the other.
So when you say coming out, this is eventually what? This is some code that you can add to your training runs. This is part of like an.
Yeah,
like
I believe he has this on a GitHub repo. He has
nice.
a GitHub
so it's
repo.
Like an example of how to run this Dharma subset of evaluations that will be outputted to your weights and biases dashboard, so you'd be able to monitor actual evaluations in almost real time.
So it's specifically stuff. Pretty much when you integrate the Dharma system with your training code loop and everything, then that will allow you. And then once you also integrate weights and biases and everything, then ideally you have a system that looks like this and has even better correlations to whatever things that you want to try and measure and look for.
So cool.
And then I guess I'll show here, just to recap on the other things I showed. We looked at neural Hermes training run here, and then if I go back again,
looks like there's different color schemas as well, just like a visually. I think there's blue and orange. So that's probably defined by the product.
Oh, and this is actually a little important side note, I guess. A lot of people don't know that weights and biases has pretty much a night mode, I think it's called. If you just go into your settings, and it's pretty easy to find in your main settings there.
Yeah, it looks so cool, so much cooler.
Yeah. Then if I go back a little bit more, the other thing we showed was being able to just dynamically look at different checkpoints of the model and see how those different checkpoints directly had certain outputs.
And also the whole concept here is the whole concept there was a concept of a report where you can prepare almost like a blog post, like more like than a blog post. You can like actually have a blog post with like terms, table of contents. You can report on everything. You can say, hey, I actually saw the reports. Reports look super cool.
Oh, that's funny. I realized. I mean, luckily I'm not leaking anything here, but I just had yeah, and this is something I could say publicly. Yeah, just had a call with Killian that does open interpreter things, and he's actually coming out, I think, maybe with a pretty big update within the next few weeks or so, maybe sooner. So you guys should look out for that, and it's a really cool project.
Yeah, Killian's a friend of the pod, and actually today I got the Spotify Wrapped for podcasters, where Spotify Wrapped for people just shows you which songs you listen to the most. For podcasters, Spotify shows you like which episodes of your podcast was listened to the most, and our episode with Killian was the most listened one for the past like season of ThursdAI, I guess, which is really cool. And so Killian is a dear friend of the pod, open interpreter, super cool, and I love the combination that happened. I think on stage at ThursdAI, where open source model folks like such as yourself, News and Alignment Labs, and folks who run tools like Open Interpreter got together and started thinking about like how to collaborate, because Open Interpreter used GPT-4, but also they have a local model that makes it completely free to run, and that would be super cool to use different tools like Mistral. So we'll definitely be on the lookout for that.
Yeah, and actually here, just a little side thing.
I'm not sharing your screen. Should I share your screen?
Oh yeah, you could share my screen again if you want.
Okay.
So here, Stable LM, Stability AI, they actually had a good example of using the report ability for making a blog post and everything. So they actually created a new foundation model. I think this is just out within the last few weeks or last couple of months. I believe it's probably the most state-of-the-art, best performing 3 billion parameter foundation model right now. And they use the weights and biases reports function, which we could tell it is from the URL, and to have this public link that they shared with people. Then there's so much functionality you could see in the reports when you truly try to use it for things like blog posts, and this is automatically integrated, and you can even expand this and even do this, like zoom in into different parts. Really cool stuff.
So cool.
And,
so this is like a combo of a blogging platform and like live dashboard metrics directly from your runs as they happen. So you can actually start writing this while the model trains, and then get the model at the end with all the final ones.
Yeah, and here you can actually see they did have benchmarks periodically throughout the training. So you could see ArcEasy is a benchmark, and Lambda. Here we have Pika. I know this involves some physical reasoning things, and yeah, it's really interesting how you could just see how it increases in accuracy in different ways throughout the training process. Yeah.
Which I think you mentioned something last time we talked. You didn't say this here, so maybe let's cover this briefly. You said that it affects kind of the performance of your run, obviously, because like you spend compute also on the inference. You spend compute on actually.
That is true. Yeah. So, let's say that you're running through a batch of 30 examples for every training step. And then let's say for every training step, you also do like 30 examples of just testing it on certain questions, like 30 different questions for every step. So it's not going to be exactly double the training cost, but like that's going to make the training compute significantly more. It's going to make the overall run take significantly longer to complete for the same amount of steps and things like that. So you do end up wanting to be mindful of how frequently you're doing these things, and then also just simply how frequently you're saving checkpoints, because then you only have, of course, a limited amount of space on whatever server or computer you're running these training runs on. Even if you're doing it in a big server, there's going to be eventually some type of limit.
Yeah, those are like tens of, sometimes hundreds of gigabytes files every step, right?
Yeah, exactly. Depending on the size of the model. Yeah, even for a 7 billion parameter model, I mean, it's going to be like it's over 10 gigabytes per checkpoint.
Wow.
Yeah.
Yeah. So
and that's assuming not quantized, and that's assuming a few things. But yeah, at the very least, even the smaller models like that are going to be at least a few gigabytes per checkpoint that you save.
Awesome. So this is a great example of a report. One thing I'll ask you is like, what's that blue thing on the top right? Why does the graph change from purple to blue? Is there like a difference?
Yeah, interesting. Happen? Okay, so here, weights and biases actually shows the legend of like what each color is, and if I hover over this, you could see it highlights that blue thing in the corner. You see? Yeah. And so this is actually technically two different runs. I'm not entirely sure. Maybe if I actually read the blog post, I would, I would know. But usually this indicates two different runs, or at least maybe two different ways of evaluating it or something.
Mm-hmm.
And yeah, and then we could see this one stopped over here. So yeah.
You mentioned
Probably.
something called warm up, where you don't immediately start doing everything. This says cool down. Maybe it's the opposite of that or something. Where at some point they decided now it's a cool down period or something, because it does look continued. Okay,
Yeah,
I'll find out.
yeah, maybe, yeah. But yeah, and then there's just a lot of cool ways that you could do
So
these things.
like a full blog post.
And then actually
system.
here, friend of the pod, Enrico Enrico
Chipotle? Yeah.
actually had some acknowledgments here. Yeah.
Awesome. Shout out Enrico.
Yeah, I think his
for
Twitter is a concept of mind.
Concept of Mind.
If anybody's interested.
Yeah, yes. And Enrico came to the pod multiple times, extending the context windows, which also I should ask if they used weights and biases for that and how it looked. But with that, I think that we can start concluding this, Luigi. So
Yeah,
you
for
recapped
sure.
everything that you said. That was awesome, dude. Thank you. I really like. I didn't even care about like who watches or what. I just like I wanted to learn, and you graciously said. You excitedly started showing me this in a DM, and I was like, "Hey, let's not do this in a DM. Let's learn publicly as much as possible for folks to see." So this like birthed the ThursdAI live kind of learning thing, and so thank you for that. That was great.
Yeah, and I hope this inspires more people to like actually use the full functionalities and capabilities of what weights and biases actually enables you to do, and able to get more insights from your models.
So what's very cool is that I started learning this week is that weights and biases traditionally was built for training models, machine learning practitioners such as yourself who do stuff either that's an LLM, which is newer, but also like other types of models as well. And they also have functionality for folks traditionally like me, like AI engineers, folks who run OpenAI calls in production. So tracing prompts and doing all these things and doing like length chain like analysis, all these things. So I'll definitely dive more into that part myself as I learn this, but also as more like I need to fine tune something. At some point, we're gonna do one of these where we're just gonna walk through like launching a run and actually seeing that work. That would be super cool. But yeah, this was great, dude. I learned a lot, and I really appreciate your time. This is like a saved resource as well, and I can safely say that this was without a hitch. We can send this to people, and people can see this and learn. So with that, I'll say thank you, and we have to plug tomorrow's ThursdAI at the end as well. So before I plug ThursdAI, I will say Nous Research and Alignment Labs, both organizations you are associated with. Both are at the top of the charts of training and fine-tuning open source models. You specifically have trained a series of models yourself, the Capybara series, which is super cool, which you have all sizes, right? Like you have the 3 billion parameter, I think, on top of what you just
there's
showed.
a 3 billion parameter version, a 7 billion parameter version, and 34 billion parameter version right now.
Yeah. And all of them, which is very cool for you, like specifically, it's a data set that you created and you've trained different foundational models and improved each one separately with the data set, which was super cool.
Yeah, and then actually, I guess I'll just plug the the last one. There's
Yeah.
something called Obsidian, which is based on Capybara 3 billion parameters, which I believe Obsidian, at least at the time of it coming out, is the world's smallest multimodal LLM. So it can actually, you can give it an image and it has the capability to see and understand the image and everything while also having a back and forth conversation.
That's super cool, super cool. And so that's all part of the work within those organizations as well. And so tomorrow for ThursdAI, you're also like, among these things, you're also a co-host for many ThursdAIs that we have. So tomorrow we're going to have a 1-year birthday celebration for ChatGPT. And we welcome folks to join that tomorrow. And this will be recorded, so folks will be able to learn from this as well. Luigi, with that, I say huge thanks to you, and we'll see you tomorrow. And I will just play us out as much as possible because we have music here. And everybody who tuned in, thank you for watching. And we'll see you in the next one. Yeah, give us comments whether or not this was helpful. Bye, everyone.